Hello all. This session is related to actual implementation of non-overlap and overlap block transfer by using assembly language program. So ALP to perform non-overlap and overlap block transfer. So already we discussed basic things related to block transfer, how it can be done or what is meaning of block transfer. Those things we have discussed in previous video. So in this video, I will discuss about assembly language program, how to write assembly language program for the same that is related to block transfer. So just I will go through assignment statement, that is write x86 64-bit ALP to perform non-overlap block transfer without string specific instruction. Block containing data can be defined in data segment. Block containing data can be defined in data segment. That is important, that we are declaring data in data segment or data section, we can say, in programming, and we are not accepting input from user. Okay. Assignment 9 is related with same block transfer, that is write x86 64 ALP assembly language program to perform overlap block transfer using string specific instruction. Prior to that, it is given without string specific instruction, and here in this statement it is given that is use string specific instruction. Block containing data can be defined in data segment. Similar manner things are given. Now I am moving to direct implementation part of the assignment. Things which required basic things, those are discussed, already discussed. So directly we will check assignment. Okay. So how to write this program, or what are the things required, or in which manner you can write assembly language program, those are important, those things we will discuss. Okay. So if you will observe here, that is section dot data. In assembly language program, three sections are there: section dot data, section dot bss, section dot text. So section dot data, variables which are required, variables which can be initialized with initial value, can be defined in data section. Okay. So which variables are declared for this assignment? Those are nothing but few messages. Okay. Related to this, already one video is published, so you can check how to declare variable, what is significance of that, what this length means. These things can be checked. Okay. So whatever data required, whatever initializations are there, those variables can be declared in data section. Basically this is important part, that is you supposed to declare array, or we can say block containing data in data section. So if you will check here, s block db 11 22 33 44 55, what it is, that is nothing but 5 elements are initialized in array for this variable. Means s block will reserve memory location of type byte. 5 bytes will be reserved. First byte or first memory location, this data. Second memory location, second, third, fourth, fifth. D block. This is important. We are initializing D block, that is destination block, as empty right now. So how it can be declared? That is D block times 5 db 0. This times is directive. Okay. 5 data bytes or 5 memory locations will be reserved with initial value 0. Okay. Just if you will check key source block and destination block, both are declared in data section. S block is having initial values, that is source values, and destination block is initialized with 0. Okay. Other part of data section is nothing but different messages are declared. You can declare message for new line, you can declare message for space if you want to give space in between. Okay, when we will execute, we will check where spaces are given. You can declare message like this also. What it means, that is nothing but within one variable or with one variable many messages are declared, but they will display in sequence. You cannot change sequence and all. Whenever you will call this variable, these all messages will be displayed. Okay, if it is required, you can declare like this also. Okay, now section.bss, as already discussed in basic video, that section.bss is for declaration of memory location for the variable. What it means, this char_ans is the variable, will reserve bytes. How many? 2 bytes. So this char_ans is empty, or we can say no initial value is given for char_ans, but it will be used in program to store some data or some result, we can say. Okay, actually this char_ans is used in display procedure. Char_ans resb2, char_ans is of 2 byte, because we have 2 byte number. So for display we require 2 byte number. So char_ans variable will reserve byte. How many? That is 2 bytes will be reserved, means 2 memory locations will be reserved. After that, macro declaration is used. Okay, related to macro, many things are already discussed: how to declare, why to declare, and what things can be given in macro. Only thing I will discuss in short, that is macro declaration for this program is done here, that is print macro. If required, you can go for read macro. Okay, and exit macro. Okay, here actually read macro is not required, you can remove that. Okay, so only print and exit macro is required. Print is for printing messages, exit, so you can use directly exit as a macro. No parameters are passed for exit, and for print 2 parameters are passed. Which parameters will be replaced? That is, these two values will be replaced when you will call print macro with parameters. You are going to pass parameters, so here you can check print and these two parameters are passed. Again print, these two parameters are passed. Okay, okay, so what next is macro. After macro declaration, section dot text, global start, like void main. We are going to in C, you are starting your program with void main. Similar manner here, assembly language program supposed to be start with label. So global start is the label. Okay, and actual execution, assembler will start from this location. Okay, now macro is called print. Message will be displayed, that is assignment number, which assignment it is. And after that, already I discussed, these sequential messages will be displayed if we are calling that variable, that those sequential messages will be displayed. Now check next, print b message, that is message which is declared with this variable before transfer. Now what next is s message. What it is? That is nothing but source block. So what output is expected? That is nothing but, first we are going to display source block, destination block before transfer and after transfer. Just I will execute this program, I will show output, and then again we will come to this point, because at the starting we are displaying source block, destination block before transfer, and after transfer also we are going to display same. So just check output, and then you will understand what is expected, and how for that, for those things program is written. Okay, So first messages are displayed. Now you can check here. You can check here before transfer, source block content, after transfer. Okay, this way we are going to display things. This program which I executed right now, that is non-overlap without string instruction. Now again coming to our point, our discussion. So first messages are displayed, then source block you want to display. So how it is displayed, how programming is done for that purpose, that is nothing but move rsi comma s block. So rsi will point to s block, so it will point to s block first location. Okay, now call this block. So here three procedures are used. So every time you want to display source block, destination block, after transfer, before transfer, so separate procedure is written. Now what is written here, that is nothing but call this block. So where it will go, it will go to this procedure. So five elements you want to display, so counter is initialized to 5. Where RSI is pointing, content will transfer to AL. Okay, that RSI should not change for because of these two, that is procedure call and print macro. For that purpose, that content is pushed on RSI called display. So in display procedure, we are converting that number into its ASCII hex. Okay, already display procedure I discussed in detail in another video, you can check that. But remember at this stage, that is nothing but now we want to display 11 first element. So that element supposed to be converted into its ASCII hex form, then we can transfer it to print syscall, it will display. Okay, so that is done in this procedure. Now next is print space 1. If you will check output, so every time after each element spaces are given. So how it is, that is nothing but in program itself we have called space comma 1, and that variable is declared here. So what it will do, it will only print or it will only give spaces in between. Okay, now 11 is displayed, space will be given. Whatever is stored on stack at this stage, again we are copying it. Now we want to display second element, increment si, decrement counter, jump if not 0, go back here. Now rsi is pointing to second element, so second element will be passed, and this loop will continue till all five elements are displayed. Okay, okay. Now coming to from where we are, or we called this display procedure. So here we called this block. Here procedure within procedure is called, you are aware about, it is recursive call. Now once you displayed, once you displayed source block, now you want to display destination block. So if you will check here, instead of s block it is written as d block. Now d block supposed to be displayed before transfer and contents will be this. So this we want to display. For that purpose, again same thing is repeated. Instead of s block, only d block contents will be displayed by using this. Okay, now call bt number. What it is, that is nothing but actual block transfer will be done. How actual block transfer can be done, that is nothing but we will check here. This program is non-overlap block transfer without string instruction. So for block transfer we are not going to use string instruction. Check, rsi is pointing to s block, rdi is pointing to d block, rcx is initialized as a counter to 5. First element where RSI is pointing because of square bracket will be copied to L. Now, whatever copied to L will copy to or will move to RDI, where RDI is pointing. Square brackets are written. Okay. So square bracket indicates memory location. At that memory location, contents will be transferred. Increment RSI, it will point to next location. Increment RDI, it will point to next location of destination block. Decrement R6. Now R6 will become 4. At the starting, it was 5. Jump if not 0, back here. Now both pointers are incremented pointing to second location. Again this will repeat for all 5 elements. Second elements will transfer, second element will transfer to destination. Again incrementation till R6 will become 0. This will be in loop, and when R6 will become 0, that is nothing but 5, 4, 3, 2, 1. Once it will become 0, this loop will end. And here RET statement, so it will come back to this statement. Now transfer is done. Now message is display after transfer. Block values after transfer. So after transfer we want to display, so this message is displayed. Now we will check what is written. Again same thing is written here. Okay, only thing is whatever will be displayed, that output should be like this, that is source block is copied to destination block. In non overlap block transfer, as already discussed, source block and destination block having separate memory location, different memory location. How it can be? That is nothing but when we are declaring S block, we declare immediately after S block, we declare D block. So remember basic point here, that is nothing but 5 memory location will be reserved for S block. For example, 1000, 1001, 1002, 1003, 1004. Immediately after that, we declare D block. So D block will start from 1005. Okay, and memory location 1005 to next 5 location will be reserved for D block. Here we have not initialized values, only we initialize those 5 elements with 0 at the starting. Now block transfer is done, messages are printed and contents are displayed. So exit, this is end of the program. Okay, so after execution of this program we just checked output, so this output is expected. Okay, this what we have discussed, that is non overlap block transfer without string instruction. Now non overlap block transfer with string instruction, where changes are, other part is same, whatever we discussed just now, same thing is there. Only things which are modified or where changes are required for string instruction, that is nothing but here in block transfer, instead of those sequential instruction, replacement is CLD REP MOVSB. REP is prefix for MOVSB instruction. Without prefix also MOVSB can be written, but as we want to copy 5 elements, so REP is used. Clear direction flag, basic thing you need to remember here, that is for string instruction these initializations are required. RSI should point to source block, RDI should point to destination block, CX should initialize with counter value. These initializations are fixed for string instruction. Those are required. You cannot initialize S block with some other register, because by default those values or those registers are going to use with these instruction. For example, clear direction flag, what it indicates, it will increment RSI and increment RDI after each iteration. Okay, so first we have clear direction flag, then move SB. What move SB will do, where RSI is pointing and where RDI is pointing, it will copy content from RSI to RDI, where at that memory location we can say. Okay, then REP prefix, because of REP prefix, after first iteration it will decrement RCX, automatically it will do this. by default, REP is for that purpose. It assumes RCX as a counter. It decrements that. If not 0, it again comes, or it will repeat this. Okay, and because of direction flag is clear after first iteration, it automatically increments this. Okay, whatever part we discuss for block transfer without string instruction, all these things will be done by using these two instructions. Remember this point. Okay, output of this program will be same as whatever we have seen without string instruction. Just I will show output of this program also. Only changes, whatever I discussed just now, those are the changes. Other program which I discussed prior to this, non overlapping without string instruction, other part is same, only replacement in block transfer. Okay, and okay, non overlap with string instruction, same output is expected. Okay, now coming to next part, that is overlap block transfer. As already discussed in previous video, that is what is basic concept of overlapping. That is nothing but few location from source are used in destination. So how it is implemented. Other points are same. Declaration is also same. Check things. Declaration is also same. S block, for example, if it is starting from 1000 location, 1000 location having this data, 1001 location having this, 1002, 1003, 1004. Now D block will start at 1005. But few location from source we want to use in destination. For that purpose, how initializations are done, that is important, that we will check. Okay, other part of the program is same whatever I discussed at the starting. Only thing where changes are, those we need to check. This change. Okay, D block -2, where it will point, check things. D block -2, it will point this location. Hmm? Check. Okay, now call display. Just I will show you output of overlap block transfer, and then we will again come to this point. With output easily you can understand ki, okay, this is expected output, and this way programming is done, or this is expected in programming. So I am just replacing code for overlap. Check before transfer, and as pointer is pointing before transfer -2, it is pointing here. Actually we are going to start destination block from here. Two location from source will be used in destination. You can overlap by using 3, you can go for 4, no problem, but few location from source should be used in destination, then it can be called as a overlap block transfer. So before transfer, just now I have shown you output. So this, these two location are used in destination, and for that purpose pointer which is pointing, that is pointing to D block -2, so it will go for last two location of the source. Display block transfer, this is important again. Pointers you can check. We are going to copy content in reverse manner in overlap block transfer. So S block +4, it will point to last location of the source, this where here, and D block +2, as we are using two location from source already, so D block +2 means 0, 1, 2. So three locations will be used from here. It will go in reverse manner and it will copy from here. Okay, if you will check output after transfer, you can check here also, that is destination block started from these location actually. So destination block displayed is this. Okay, these two are used in destination. So actually from here destination block start 11, 22, 33, 44, 55. Okay, just check program. Okay, now whatever I discuss here, that is in reverse manner. So point to last location of the source, point to last location of the destination. RCX5, other things are same. Only this pointer where they are pointing, that is very important. And once block transfer is done, we are going to display content after transfer. Again, same thing you can check here, -2. Okay, whatever I discussed prior to this also, that is nothing but after end of source block immediately we declared destination block. So whatever last location of the source block, next location will be destination block. For example, 1000, 1001, 2, 3, 4. 1004 is the last location of source block. So D block will start at 1005. This understanding is very important because whenever you are going to use pointer, this should be clear to you. Okay, understood? So next part is whatever we discussed, that is without string instruction. Again, with string instruction, other part is same, only replacement is here, and which is important. STD, set direction flag. One more point here also, you can check decrement because they are pointing to last location. You supposed to decrement those content. So it will point to second last location, next location, next location. In reverse direction, it will copy. And for that purpose, only in string instruction or where in next program for overlap block transfer with string instruction, direction flag is set. Because of setting of direction flag, after each iteration, SI and DI are going to decrement. CX counter already it will decrement. If not 0, it will repeat this instruction again. Okay, whatever written here, same thing is going to implement, same thing is going to use only by using these two instructions. Understood? So output expected is this for overlap block transfer. Try to execute by using this online software and check things. And prior to watching this video, you're supposed to watch basic things, then only you will understand this implementation point. Because in previous video of same, I discuss all points related to what is non-overlap, overlap block transfer basics, how it can be done, algorithms, and instructions also. So prior to watching this video, you're supposed to check for previous video that is related to basics. Okay, so try to implement check output of the same. So once you will check output, you will understand ki okay, this manner you supposed to implement, and this is basic logic. Then for overlap, this output is expected. In non-overlap, similar manner whatever we discuss. Okay, remember basic, that is no, in non-overlap block transfer, source block and destination block memory locations are different, and in overlap block transfer few locations from the source are used in destination. Okay, because of that only it is called as a overlap block transfer.